Okay, so we looked at sort of routing concepts in chapter 14. And so chapter 15, we actually talk about static routing. And so we have certainly was mentioned in the previous chapter, but we're going to do a little more in depth, and we're actually going to do some. So we're going to look at static routes, and so we'll look at the command and the syntax for that command. And so we'll configure IP static routes, we'll configure IP default static routes. There is another option with static routes called a floating route, which we'll describe in there. And you can also do static host routes if you feel the need. Okay, so static routes are commonly implemented on a network. This is true even when there is a dynamic routing protocol configured. So static routes can be configured for both IPv4 and IPv6. Both protocols support the following types of static routes. And so there's a standard static route, which just specifies a network destination. A default route, which says basically the rest of the world is that away, and so you'd normally point that at your ISP. There's a floating static route, which is actually there for a backup route. And so you might have a primary link between two offices, and that's your preferred route, and you might run your dynamic routing protocol over that. If that link dies and you've got a backup route, you could actually use what's called a floating static route to implement that when you automatically implement that when your primary link is down. And so a summary static route can be used to summarize networks so that you can decrease the size of the routing table, which has several benefits, including quicker searching of the table. So static routes are configured using the IP route or IPv6 route global config commands. Okay, so we didn't actually talk about the rest, but anyway, when you're creating a static route, you've got three major options when it comes to telling the route how to get to its destination. And so the next hop can be identified by an IP address. And so basically the next router along the way for this route is to IP address such and such. Directly connected static route, which means you instead of specifying an IP address, you actually specify an exit interface as the instructions on how to find the destination. And then you can also do a combination of the both. And so where you specify both the next hop IP address and the exit interface. Now, doing the exit interface alone is actually quicker, but it will not work on every network. If you've got a multi-access network, that route will not work. Because if your next hop is an Ethernet network with quite possibly multiple routers, you actually need to tell it exactly which router it needs to go to. And so that's why you need a next hop IP address. But with the next hop IP address, the router actually has to search the routing table twice. So that makes it slower. While with with an exit interface or directly connected static route, it only needs to use that once. But of course, as I said, you can't use it on every network. And so basically, the best of both worlds is when you specify both bits of information. And so the next hop, of course, will allow you to use it on any network, and the exit interface will negate the need for a second lookup. And so it's a good option to have the best of both worlds, as I said. Now, the IP route command for IPv4, the syntax is put here. And so IP route, of course, is the command, and then you need to specify the network that we're advertising. So be that the destination network, basically. And then we need to tell it what its subnet mask is, and then we need to give it instructions on how to get there. So that's either your next hop IP address or exit interface, or both. And then distance. Did I mention administrative distance in chapter 14? It's a while ago now, isn't it? But anyway, so administrative distance is actually used as a tiebreaker. If you've got more than one option to get to a destination network, the one with the lowest administrative distance is the one that will go in the routing table. Now, static routes by default have an admin distance of 1, which is not quite as low as you can go, but pretty close. And so that's fine, but maybe if you want to do that floating address route that we'll talk about a bit later, you can actually increase the distance so it's actually not used unless it really must be. Now the distance, because it's in the square brackets there, means it is an optional setting. So if you don't set it, it will be set to 1. All right, so the IPv6 route command, of course, is for IPv6. And of course, the major difference is we don't use a subnet mask with IPv6, we use the prefix length. And so again, you can do next hop IP address, exit interface, or both. And of course, the distance is another option. So the parameters, of course, are the same, of course, apart from the fact that they're IPv4 addresses, IPv6 addresses. All right, so we've got a topology here that we're going to look at. And so it's dual stack, meaning there's both IPv4 and IPv6. There is currently no static routes are configured for either of those protocols. And so each of these routers only knows their directly connected networks at the moment. So PC1 will not be able to ping PC2 or PC3. So we do not have connectivity yet because router 1 doesn't know about that network on that network, the ones that are not directly connected, and so on. And so router 1 and router 3 only know 2 networks, router 2 knows 3 networks, but of course there's 5 networks, so none of them know everything. Okay, so each router has entries only for the directly connected networks and associated local addresses. So on router 1, as I said, you've got 2 directly connected networks, and of course you've got the local addresses. And so that works nice. You can ping routes in the networks that you do have in the routing table. You can't ping ones that you don't. So, of course, with IPv6, the situation's much the same, just that, of course, it's the IPv6 addresses that are incomplete. Okay, so how do we configure IP static routes? And so in that topology we were looking at, on router 1, there were 3 networks that router 1 did not know about. So 172.16.10, 192.168.10, and 192.168.20. And so they're the 3 extra routes that were required. And so putting them in with the IP route command, supplying the subnet mask, and of course the next hop IP address is going to be router 2 for each of them. Because, you know, there was router 1, everything else was, you know, everything else had to go via router 2 when it came from router 1. And so now that those static routes are in the table, router 1 has all 5 networks in its table, the 3 static routes plus the 2 connecteds. So of course with IPv6, you need to turn on unicast routing. I think I've said that before. And then you then put in your 3 routes that it doesn't know. And so again, we've added the 3 statics that plus the 2 connectors, and so IPv6 also knows all 5 networks. So that's nice. Router 1 knows how to get to all the networks. That still won't fix connectivity though, because router, that's great. If was it PC1? If that pings the other ones, the packet will go to router 2. And if it's pinged PC2, it will get to PC2. But when PC2 goes to return it, router 2 will go, well, I don't know how to find that network. And so router 2 doesn't have complete information yet, so we haven't fixed anything completely yet. We're only part way there. So, of course, with IPv4, you had the option of using an exit interface. And so on that diagram, it was a serial link, I mean. And so you can do exit interface instead of next hop IP address, and that would work just as well. And so again, you have your static routes here, and that, yeah, again would work just as well. And of course, you can do the same thing with the IPv6 routes. You can use an exit interface instead of the next hop. Okay, now a fully specified static route. Oh, typo. Oh, no, not. So basically here, on a fully specified static route, both the exit interface and the next hop IP address are specified. This form of static route is used when the exit interface is a multi-access interface and is necessary to explicitly identify the next hop. The next hop must be directly connected to the specified exit interface. Using an exit interface is optional, however, it is necessary to use the next hop address. It is recommended that when the exit interface is an Ethernet network, that the static route includes a next hop address. You can also use a fully specified static route that includes both the exit interface and the next hop address. And so here's the example: IP route, destination network, subnet mask, exit interface, and next hop IP address. And as I said, that's the sort of best of both worlds. And so again, you can do that with IPv6 static routes as well. So this example down the bottom here, your destination network, your prefix, your exit interface, and your next hop address. And that works nicely. Now, static routes. Did I miss a screen? No, I didn't. So the reason the fully specified static route must be used is because IPv6 linked local addresses are not contained in the IPv6 routing table. Linked local addresses are only unique in a given link or network. The next hop linked local address may be a valid address on multiple networks connected to the router. Therefore, it is necessary that the exit interface be included. The following example shows an IPv6 routing table entry for this route. Notice that both the next hop link local address and the exit interface are included. So you can see that there. So how do you verify? So show IP route or show IPv6 route are, of course, certainly very useful. Shows you the routing tables for both IPv4 and IPv6. Of course, ping or trace route will actually test that it works. That's always good too. And so, of course, you can get a little bit more specific with the show IP route. You can do show IP route static, and it will just show you the static routes. You can do show IP route network, and that will you specify which network, and you'll just get that routing entry. Or you can do a show running config and just see the section with IP routes in it. And so, of course, for IPv6, just put a v6 after the IP, and those commands will all work still. Okay, so default static routes. Now here, we've got what people call a stub network. So from this router, it's basically dead end. Now you've got your little network here, but nothing else. There's no other destinations. So that's what they call a stub network. And so this is a stub router because it's connected to a stub network. And so basically, when it comes to this router, it doesn't really need a whole lot of information in its routing table. And of course, this is very familiar to your home router, in that you've got your local network here, you've got your link to your ISP here, and your router doesn't use a routing protocol. It just has a default static route saying, all right, the rest of the world is via my link to the ISP. And so that's the only decision making your router at home makes. And so basically you can do exactly the same thing with a Cisco router by putting in a default static route. And so a default static route is a static route that matches all packets. A single default route represents any network that is not in the routing table. So of course your router at home only has 2 networks. your local network, and of course the network that joins it to the ISP. But you can get to anything, can't you? And that's because of the default route. Routers commonly use default routes that are either configured locally or learned from another router. The default route is used as the gateway of last resort. Default static routes are commonly used when connecting an edge router to a service provider or a stub router, a router with only one upstream neighbor router. The figure shows a typical default static route scenario. So I've pretty much already explained it. So how do we do a default route for IPv4? And so the command syntax for that is similar to any other static route, except the destination and mask are all zeros. So quad 0 destination, quad 0 mask, and so basically that's all you need to do, as you can see here. And then of course you need to give it forwarding details. What is the default route? And so that of course could be your next hop IP address or your exit interface. So the default static route is commonly referred to as a quad 0 route. Now the important factor here is actually this mask, which basically means 0 bits need to match for this route to be a match. That's basically what it's saying. And so any address matches it. It's the poorest possible match, but it is a match. And so I think you might have seen in previous chapters that the longest match is the best match. So if you've got any match that's longer than this one, it'll use it. But if there is no matches apart from this one, it will use this one. So when it comes to IPv6, this is where it actually gets shorter on IPv6, because of course, again, it's going to be all zeros, but of course there's a shorthand way to specify all zeros in IPv6. That's 2 colons, isn't it? Fill the gap with zeros. Well, in this case, maximum value, you're getting 128 zeros. And of course the prefix length is 0 long, and so just /0. So that means the same as that, basically, but in the different notations. And so again, you just need to give a next hop IP address or exit interface. So here's an example, or two. And so for a default route, here you can do IP route, quad 0, and then the next hop IP address. Of course, for IPv6, it's the destination that we spoke about earlier, and then the next hop IP address. Of course, it could be an exit interface as well. So when you've got a default route, at least with IPv4, the gateway of last resort line changes. So if we go, I might just go back a few slides. When did we have a routing table? See, too many. Gateway of last resort is not set. What that says is there's no default route. So that's the default behavior. Once you've set an IP, a default route, this is at least for IPv4. Back to the right slide again, come on. Now that the one's been set, you can see the gateway last resort is, and it tells you at least some of the information. And so you can see here also that there's a route that has a source of static. The star, if you look up here, it should be in this, yeah, candidate default route. And so again, you've got quad 0/0 and the next hop information there. So, so that there's 2 ways that it's actually indicated in IPv4 routing table. You've got a default route. Now, for an IPv6 routing table, they don't give you the gateway of last resort line. So you need to search for a static route that looks like that, basically. So notice that the static default route configuration uses the ::/0 prefix for default routes. Remember that prefix length in the routing table determines how many bits must match between the destination IP address of the packet and the route in the routing table. Of course, that prefix indicates that none of the bits are required to match. As long as a more specific match does exist, does not exist, the default static route matches all packets. So again, the 0 length, it's the worst possible match, but it is a match. All right, now floating static route. I have mentioned it briefly before. So another type of static route is a floating static route. There are static routes that are used to provide a backup path to a primary or static or dynamic route. The floating static route is only used when the primary route is not available. So to accomplish this, the floating static route is configured with a higher administrative distance than the primary route. The administrative distance represents the trustworthiness of a route. If multiple paths to the destination exist, the router will choose the path with the lowest admin distance. By default, static routes have an administrative distance of 1, making them preferable to routes learned from a dynamic routing protocol. They seem to think you know what you're doing. That might be true, it might not be. But anyway, the administrative distance of a static route can be increased to make the route less desirable than that of another static route or route learned from a dynamic routing protocol. And this way, the static route floats, and it is not used when the route with a better admin distance is active. And so here, basically, we've got a default route, and that's the next hop. We've obviously got a standby default route with that next hop, and then that 5 there says the admin distance is 5. And so, of course, this will have an admin distance of 1 because that's the default setting, and so this route will be used. But if the router can't find this hop, if it can't find this next hop anymore, it will remove that from the routing table and go, oh, I've got another route to that. And so it will then use this. And so that's basically what they mean by floating. It's just sort of hanging out there waiting to be used. So, of course, this is a similar example, but for IPv6. And so, again, this one just has the admin distance of 5, and so it won't be in the table unless the primary route dies. So show IP route and show IPv6 route output verifies the default routes to router 2 are installed in the routing table. Note the IPv4 floating static route to R3 is not present in the routing table. Okay, so testing the floating route. And so, of course, what would happen if R2 failed? To simulate this, R2 shuts down both of its serial interfaces. R1 automatically generates a syslog message for the link going down. And a look at R1's routing table would show the secondary route being used. Yeah, except that where is 10? Where is 10, 10, 10, 2? It's a bit strange, but anyway. Okay, now you can also do host routes. Now a host route is an IPv4 address with a 32-bit mask or an IPv6 address with a 128-bit mask. The following shows the 3 ways a host route can be added to a routing table. So, of course, we actually get a host route every time we define an IP address on an interface. And so that's that L entry. That is actually a host route. It's configured as a static host route or a host route automatically obtained through other methods. But we won't talk about that any further. So iOS automatically installs a host route, also known as a local host route, when an interface address is configured on the router. A host route allows for more efficient process for packets that are directed to the router itself rather than to a network it's connected to. This is in addition to the connected route, and so that's why we have the C and the L. If there's a packet that's destined for the router itself, the routing table will tell it that instantly, and bang, it can actually process it itself. And so we've always had the C routes in the routing table. The L route is a newer addition since iOS 15 was released. A host route can be manually configured static route to direct traffic to a specific destination device, such as the server shown in the figure. The static route uses a destination IP address and a 32-bit mask, or all 255s, and a /128 for an IPv6 one. So how do we configure it? So IP route, we specify the host's address, we give it a 32-bit mask because it's IPv4, and then we give a next hop IP address. And that will appear in the table as a /32 route. Of course here, much the same process. except it's a /128 route. And of course, next hop IP address. And so here is an example of an IPv4 host route. And here's an example of an IPv6 host route. I've got to admit, you won't do this very often. So, configure an IPv6 static host route with link local next hop. For IPv6 static routes, the next hop address can be the link local address of the adjacent router. However, you must specify an interface type and an interface number when using a link local address as the next hop, as shown in the example. So here we got a next hop of FE82. Of course, FE80 is on every network, and so it needs an interface if you're doing that. First, the original IPv6 static route is removed, then a fully specified route configured the IPv6 address of the server. And so again, it's 128-bit. All right, that's it for the chapter. Just a bit of a rehash. So static routes can be configured for IPv4 and v6, and both protocols support the following types of static routes. So that be standard, default, floating, summary, and also host. But anyway, when configuring a static route, the next hop can be identified by an IP address, an exit interface, or both. How the destination is specified creates one of the three following types of static routes. So next hop, directly connected or fully specified. IPv6 static routes are IPv4 static routes, are configured using the following global interface configuration command. IP route, then the destination network, then the subnet mask, and then the forwarding information, be that exit interface, IP address, or both. You can optionally put the administrative distance on the end. So IPv6 routes are configured in much the same way in global config mode. So IPv6 route, destination followed by prefix length, followed by forwarding instructions, optionally followed by distance. In the next hop static route, only the next hop IP address is specified. The exit interface is derived from the next hop. When configuring a static route, another option is to use the exit interface to specify the next hop address. Directly connected static routes should only be used with point-to-point serial interfaces. In a fully specified static route, both the exit interface and the next hop IP address are specified. This form of static route is used when the exit interface is a multi-access interface and it is necessary to explicitly identify the next hop. The next hop must be directly connected to the specified exit interface. In a fully specified IPv6 static route, both the exit interface and the next hop IPv6 address are specified. A default route is a static route that matches all packets. Default routes are commonly used when connecting an edge router to a service provider network or a stub router. The command syntax for IPv4 and IPv6 are quite similar, and so the destination is 0, the subnet mask is all zeros, and of course then you put in the forwarding information. It's just that we have to do two quad 4s for IPv4, but here we can just do 2 colons, a slash, and a 0. Floating static routes are static routes that are used to provide a backup path to a primary static or dynamic route in the event of a link failure. Floating static route is configured with a higher administrative distance than a primary route. By default, static routes have an administrative distance of 1, making them preferable to routes learned from dynamic routing protocols. So IP floating static routes are configured with using a distance argument to specify an administrative distance. And so if you're using OSPF, it's got an admin distance of 110. So if you've got a floating static route to back it up, you would need to make that distance higher than 110, basically. A host route is an IPv4 address with 32-bit mask or an IPv6 address with a 128-bit mask. There are 3 ways a host route can be added to a routing table, either automatically installed from basically the configuration on the router. It can be a static one or automatically obtained through other methods, but we're not going to talk about that. iOS automatically installs a host route, also known as a local host route, when an interface address is configured on the router. A host route can be manually configured static route to direct traffic to a specific destination device. For IPv6 static routes, the next hop address can be a link local address of the adjacent router. However, you must specify an interface type and interface number when using a link local address, because, of course, link local addresses are not unique to a particular network. To do this, the original IPv6 static host route is removed and a fully specified route is configured. There's the logo, so we're done.